Certified Hadoop developer. I'm the Big Data Certified Analyst, and I'm the chamber member of IBM's Big Data University. This is a brief introduction of mine. Let us just start this with a simple example. Let us consider that we just opened a bank account somewhere in 2000. After 13 years, that is in 2013, we approached the bank and we asked them for the past 3 months bank statements, which you can get hardly in 30 minutes or at most of 1 hour of time. The very next day, we approached the same bank and we asked them for the past 3 months bank statements, which you can't absolutely get in the span of time of which when you got your 3 months bank statements. We all know that the main reason is all your data will be moved to the backend, stored, and then we'll be generating some reports which are very much important for the organization's development of storing your data and processing your data. There are several drawbacks, and let us discuss what all are the existing drawbacks in the storage and processing, and how Hadoop could be an answer, and what is the drastical change that Hadoop made in this process. So let me just go ahead. Data storage and data processing literature survey. Well, I just classified the data as people's data and machines data, where we the people usually upload images, videos, update status, tweets, likes, comments, shares, tags, applications, ads, postings, what's not. Everything in your social networking sites and your e-commerce site will be just generating a large magnitude of data. And your machines also generate a large amount of data. RFID readers, sensors, GPS traces, satellite communications, and your log files. And since I just developed these presentations long ago, the first challenge was to the organizations like Google, Yahoo, Amazon, and Facebook, because these are the people who usually deal with large magnitudes of data. But now this is the problem to almost all organizations. About 90% of the organizations are suffering from this data. And at last I just passed a bold statement stating that existing methodologies were becoming inadequate in processing those large data sets. Let me just share you why I passed that statement and what all are the drawbacks in the data storage and data processing. So let me just start with data storage. When I talk about the data storage, the first and foremost word which will straightly strike away your mind is nothing but RDBMS, which has been ruling your industry from the past 2 decades. Well, the RDBMS has certain challenges, like there is a storage saturation limit where your RDBMS cannot withstand with large magnitudes of data. It can get hold up with hundreds of terabytes and petabytes of data. Its performance will be degraded. And schema on write. So let me just share like this. Let us consider that we just had a data set which we want to just store in your RDBMS. We'll be defining a schema on that, and then we'll be uploading the fields into that schema. We'll be defining the schema which exactly fits to your data set. And suddenly that there was another data set or some other fields came into the picture which are not defined in your schema, which becomes typical again. So we need to know what sort of data you're just going to get. So basing on that, you'll be defining your schema. And above all, the most important and the most sounding drawback is there is no support for your unstructured data. When I talk about the unstructured data, the data on which you can't define any schema is nothing but your unstructured data. your XML files, your HTML files, your JSON data, your image files, your audio files, your video files. All this comes under the unstructured data. And unfortunately, about 90% of the data is your unstructured data, where your application has utterly failed at this scenario.
Vignesh, Swati here.
Yep.
Can you please mute everybody so that we will not hear any echo?
Even I tried it, but because I don't have that right, because I'm not the organizer, I don't have the mute all option with me.
No, I'll mute everybody. Okay, this is much better. Hi, Vignesh.
Right. Okay. Right. I just got it. I hope my voice is audible to all. Yeah. Well, so let me just continue. Well, we are at the data storage perspective, where we just discussed about the drawbacks of your RDBMS. Well, we usually purchase this disk space from the SAN storage, where we'll be using FC disks, fiber channel disks, for storing your data. And the latest enhancement is your solid state drives. Well, we usually purchase this at the factor of 24 TB disks, and we'll be providing the redundancy for your data using the mirroring or the RAID levels. And we all know the word SAN itself is very much expensive, but still we don't have any alternative. We have been following that. So on an average, let me just conclude regarding the data storage is the most sounding drawbacks are there is no support for unstructured data, and it is expensive. So these two are the most sounding drawbacks. Let me just switch on to the data processing. We usually move your data to the backend, and we'll be storing the large magnitude of data either in Teradata or Datagen, where we'll be just generating reports out of that. And Teradata is a very costly approach in handling the data, but no alternative, but good at performance, so we have been following that. Though Teradata is very good at performance, it has a drastical drawback, that is your block size. The block size of Teradata is small, hence increase your disk seek time. I'll talk about what exactly do I mean by disk seek time. So data processing is also costly because of high-end hardware. Your Teradata will demand for blade servers and Spark processors to work on, which are expensive. If you want to transfer your data from the front end to back end, we usually need to seek help of network. The word network itself has several drawbacks, where we have been using FC cables, fiber channel cables. The internal mechanism goes on with total internal reflection will be transferring your data. In this scenario of transferring your data, we need to retrieve the data initially from the disk, read the complete data from the disk, and then transfer it across the network. In this due course of reading the data initially from the disk, there is no problem with your network. Your network could able to transfer the data at gigabytes per second. That's an excellent speed, but your disk cannot retrieve the data at that much fast. Hardly your disk speeds are congested up to 500 Mbps. But your network is quite good. It can transfer at gigabytes per second, and hence it leads to a bottleneck problem. This is your network bandwidth where it can transfer at gigabytes per second, but this is your disk speed where it was congested at megabytes per second. And this is the problem over here. And we usually use the Unix flavor of operating systems at the data storage. And we all know the block size of Unix is of 8 KB. Let us consider a simple example. When you want to store 64 MB of data in your Unix file system at 8 KB block size, how many blocks do we need? Approximately of 8,000 blocks because of the 8 KB block size. And when you want to retrieve the same 64 MB of data, your disk head need to be moved from one block to another block and so on for 8,000 blocks, and the time taken by your disk head to retrieve your data from one block to another block is nothing but disk seek time. So since there is a lot of disk, the disk seek time is much, and there is a lot of network issue, leads to a bottleneck. These are all your network constraints, and this is our overall journey, what we discussed till now. This is the place where you can't store your unstructured data, and where you can't store large magnitude of data, and where it is becoming expensive. And this is the place where you'll get your bottleneck problem, and this is the place where it is becoming much expensive while processing. And we usually purchase this in the factor of 24 TB drives. So this is the overall discussion of ours, and we need an alternate technology which will handle your unstructured data, which will eradicate your network issues, which will vanish your disk seek time, and which should not be expensive. Your upcoming technology should have all these four. Am I not audible? Hello? Okay, fine. So should I just continue? Yeah. Okay, let me just continue. So according to IDC statistics, the world's data by the end of 2020, they're expecting this to reach 40 zettabytes. And here I mentioned what is zettabyte is. 1 zettabyte equals to almost 1024 cube terabyte. Let us just make approximate. So 1 zettabyte equals to 1000 cube terabyte. That is 1 zettabyte equals to 10 power 9 terabyte. So 40 zettabyte equals to 4 into 10 power 10 terabyte. 4 into 10 power 10 terabyte is not a simple figure. Just imagine how many 24 TB drives do you need in order to store 4 into 10 power 10 terabyte of data? How many days do you need in order to transfer this data across your bottleneck problemed network? how many $1,000,000 do you need in order to process this 4 into 10 power 10 terabyte of data? The thought itself indicates that we are choosing a wrong path. We need an alternative. That is your Hadoop. And above all, 80% of this 40 zettabyte of data is unstructured, where your RDBMS utterly fail. And we the people are the main sources of unstructured data. Again, we'll be uploading our status, likes, comments, shares, tags, applications, ads, postings, tweets, whatnot. These are all the sources of our unstructured data. And we classified mails as your semi-structured data, where if you consider a mail, we will be having to CC, BCC and from. We can just define a schema on it. We can define a schema on to, CC, BCC and from. But can you define any schema on the text body? And majority of the mails may not have any attachments, and many may have attachments. And the attachment might be an image file, a audio file, a video file, a XML file, which is unstructured again. But you can define the schema on the addressing fields like to, CC, BCC and from. So that's the main reason why we classified mails as semi-structured data. And machines data like RFID readers, sensors, GPS traces, log files, which are usually disabled at the server level. We'll be disabling these log files at the server level. But if you have the technology to deal with those log files, you can generate money out of that dump. And that is the place where about 90% of the e-commerce is currently focusing on. They are generating money out of that dump. We processed the log files of Flipkart, where we generated 38% of their revenue, which is quite good. So before just going to Hadoop, I need to talk about this word, crazy word, big data. Well, big data is not a technical term. Any data which has several characteristics could be addressed as big data. And the characteristics should be possessed by your data in order to get addressed as big data is volume, velocity and variety. Volume indicates the magnitude of data, whether your data is at the range of terabytes, petabytes, exabytes or even at the range of zettabytes. Variety indicates your data is structured, unstructured or semi-structured. Velocity is the rate at which the data is being generated and the rate at which you need to process that generated data. If your data is of highest or high volume, ranging from terabytes, petabytes and so on, if your data is semi-structured or unstructured and which is getting generated too much faster, that is your big data. This is a tricky problem for the industry now. And now to handle this big data, this is your Hadoop, which can handle this in a well-versed, excellent way. Well, let me just share you how Hadoop can handle this big data and how Hadoop will be an answer for all the existing drawbacks. How Hadoop can overcome that. Whenever I address as Hadoop, Hadoop is always at a cluster level, where a cluster is nothing but combination of nodes connected through a network, and a node is nothing but a computer. So let me just make like this. Hadoop is nothing but combination of computers connected through a network, and when I install Hadoop on each and every computer, it simply becomes a Hadoop cluster. And Hadoop has two major components within it, HDFS and MapReduce. HDFS is for storage and MapReduce for processing simply. HDFS indicates Hadoop distributed file system. Well, distributed file system is not new, it's old. But Hadoop distributed file system is something new, where the default block size is of 64 MB. Just imagine 64 MB block size is not a simple figure. Let us consider an example where you want to store 128 MB of data. You would like to store 128 MB of data in your Unix file system. It will consume 16,000 blocks at 8 KB block size. And the same 128 MB of data in your HDFS will consume just 2 blocks. In the previous case, your disk head need to be moved for all those 16,000 blocks, but in this, your disk head need to be moved only twice. Thus, your disk seek time is almost vanished. One of the drawback was already overcome. And you are storing your data directly in your file system, where you can that means you can store your unstructured data, because we could able to store your images and your movies on your laptops and on your PCs, because you are storing it directly in your file system. And the same here also. Since you are storing your data directly in your file system, you can store your unstructured data. So hence, there is support for unstructured data. And you will be storing your data on your cluster, and you will be processing your data across the same cluster. So on the same cluster, you are storing and processing your data. The both is happening on the same cluster. So almost your network issues will be eradicated, because your computation, your MapReduce program will be moving across the cluster towards your storage data. And I'll talk much regarding this. I'll talk much regarding that. And since you are making the both on the same cluster, almost your network issues will be vanished away. And whatever the hardware you are using in Hadoop is of commodity hardware. Your Hadoop does not require blade servers and Spark processors to work on. It will work with commodity hardware, cheap hardware. That's the main reason on the 4th day, on the 5th day of our journey, we will be just installing Hadoop cluster on your PCs and on your laptops, because your laptop is a commodity hardware. Your PC is a cheap hardware. My laptop is a cheap hardware. And Hadoop is an open source. What else do we need? We eradicated your network issues. Your disk seek time got reduced. It can handle your unstructured data, and it is working with cheap hardware. Your expenses became down. So all your drawbacks were vanished. What else do we need? And this is what I have been talking about. Hadoop can make data storage and data processing at one hub, and it is the fastest processing. Well, this is not what Vignesh is boasting about Hadoop. This is the IBM's declaration, where we processed 1 terabyte of pure unstructured data with your RDBMS, which consumed 28 hours to process it. And the same 1 terabyte of data using Teradata, which consumed 6.5 hours to process it. The same 1 terabyte of data and the same unstructured data using Hadoop 180 node cluster consumed 3 minutes 27 seconds to process it. The same 1 terabyte of data and the same unstructured on 180 node Hadoop cluster, but using the latest architecture, YARN architecture, the latest enhancement on top of Hadoop, which consumed just 1 minute 19 seconds to process. Just imagine the range. 28 hours, 6.5 hours, 3 minutes 27 seconds, and 1 minute 19 seconds. That's drastical. And that is where your Hadoop lives. And above all, you could get these privileges at cheap cost. This is what I have been talking about. When you want to process your data, big data with your Hadoop, when you upload it to Hadoop, your data will be broken into 64 MB blocks, and those blocks will be scattered among your nodes of your cluster. And these blocks will be stored on your hard disks of your cluster. It will be stored on your hard disks of cluster. And when you want to process this data, which was stored on your nodes, you'll write a computation. A computation is nothing but a simple MapReduce program, which will be written in Java, Ruby, Python, Perl, or even C++. We'll be defining a simple MapReduce program. We'll be making a jar file out of it, and it's your jar file which will be transferred to across your data, which will be transferred towards your data. Your data is stagnant. Your data is stagnant on your nodes, and it is your jar file which will be moving towards your data. So obviously your network issues will be vanished because its computation hardly will be of few KB. And on each and every node, on an average, if you have a peep, it's a parallel processing. Your data is getting parallelly processed since it was already distributed, and your data is getting parallelly processed. And on each and every node, there will be further parallel processing occurred on. In this node, there will be further parallel processing for your stored data. On this node, the same. So on an average, it's not a simple parallel processing, it's a massive parallel processing. And this is the Hadoop core concept, where it is easier to move the computation rather than moving the data. Traditionally, we have been moving your data across the network. And in Hadoop, your data is stagnant and it is your computation which is moved towards your data. And it is a massive parallel processing for ease. And it is easier to deal with small data pieces rather than dealing with big data sets. That's what we just went on with distributed file system. And above all, we could get this with commodity hardware, cheap hardware. This is a quite common, normal, regular question what I usually face with many of the people. That's why I just included that in my slides. They usually ask me, why should we go for a new framework called as Hadoop in order to process your data in a parallel way and store it in a distributed way? Why should we go for a new framework and why should we go for a new infra? Can't we achieve this with the existing RDBMS storage, spread it across a group of disks, and I will process each and every disk parallelly? So they will usually ask me like this. They'll purchase 10 disks, and on each and every disk they'll be just having their RDBMS, and they'll be just spreading your data all across these 10 disks, and on each and every disk they'll be just processing parallelly. Yes, that's a very good approach, excellent thought. But what about your disk seek time? And what about your data type? Can you store your unstructured data in your RDBMS? And what about the replication, providing the redundancy, which will be expensive? So the thought is wrong. We need an alternative. That is your Hadoop. Perhaps you might have heard about these words. Whenever I address as Hadoop, it is HDFS and MapReduce, the most major two components out of it. But for the people who are not from any programming background, if they still want to work on with Hadoop, yes, they can go ahead. We have something called as PIG, which is a ELT processing. It is not ETL because we need to address it as ELT, extract, load, and then transform. We have something called as PIG, which has its own scripting language called as PIG Latin, and whatever the script you write, that will be internally converted into a MapReduce job. And the scripting language is much easy, not to worry regarding that, because I'm not from scripting background, but I have been working on PIG from the past 9 months in a most comfortable way, the easiest of all the ecosystem components. And we have something called as Hive, which is just like your SQL. And whatever the query you write in Hive, that will be internally converted into a MapReduce job again. Usually Hive will be used to generate reports by integrating this with any of the BI tools, like your Tableau, Spotfire, or KarmaSphere. That's your Hive. And we have Scoop, which is used to import the data from your RDBMS to HDFS. Scoop is a utility tool to import the data from your Oracle, MySQL, SQL Server, or DB2 to import that to your HDFS. And we can even import the data from Teradata to HDFS using the Scoop, but using a Teradata connector, again an enhancement. And Avro is the one to deal with the serialized files. And you might have heard about this word, HBase, the NoSQL database, the most crazy word, NoSQL database. Well, the name itself will convey you, it is NoSQL, not only SQL. You don't have anything like primary key and foreign key, no normalization at all. And your data will be stored in the key value pairs. and you can store your unstructured data also. We have almost 150 NoSQL databases, out of which the most famous are HBase, Cassandra, MongoDB, Neo4j, Couchbase DB, and Accumulo. These are all the most sounding NoSQL databases. And Zookeeper is a service, is a coordination service among these ecosystem components, which will come by default when you install your HBase. Your Hadoop is an open source, and what each and every ecosystem component, what I have been addressed here, are open sources. Your Hadoop itself is an open source, and all these ecosystem components are open sources. But can any organization dare to deal with open sources without any technical support? Though this is an open source, since it's an open source, if I have any issue, I will not get any customer support. There will not be any well-versed customer support to deal with this if I have any issue. So yeah, any problem regarding the audio? Right, okay then. So let me just continue. It's an open source. Your Hadoop ecosystem components are open sources, and Hadoop itself is an open source. But since it's an open source, you don't have any well-built GUI for this, and you don't have any technical support for this. And if you want to work with these ecosystem components, you need to download them manually, install them manually, and configure them manually. And in this due course, you will not have any technical support. Owing to these, there are several organizations which came forth, like Cloudera, Hortonworks, Big Insights from IBM, HD Insights from Microsoft, Amazon Web Services, EMC Squares, Greenplum, HP Pivotal, and Astrodata from Teradata, Intel Hadoop, Oracle Hadoop. So these are all the several organizations which came forth, and they will offer you a very good customer support, an excellent GUI, and they will provide all these ecosystem components as a package. We have almost 14 distributions now. And these are all the organizations who have been following Hadoop, and by the end of 2015 we are expecting about 90% of the industry must migrate for Hadoop if they still want to exist in this competitive world with the growing data. So this is a brief introduction of Hadoop, and now you can unmute all and you can fire me with your queries. You can unmute yours. I'll ask Mr. Swati to unmute you, and so that you can fire me with your queries. Can you please unmute all? Hello? No. Right. Hello? No. Right. Please go ahead. You can fire me with your queries. Please go ahead. You can fire me with your queries. Yes, I got yeah. So well, I'll just show you the contents, what will be discussed now. So this is the journey with development. Right, okay, fine. Pankaj, it's right. So it will be quite good if you just type your queries over here, so there will not be any echoes and any disturbance. So these are all the contents, the basic Hadoops initially, and later on we'll be just going with Hadoop installations on your laptops and on your PCs, where we'll be just going ahead with several distributions of starting with Apache and then Cloudera and then with Hortonworks. And When I talk about the Hadoop development, we will be initially starting with a simple MapReduce program and performing Hadoop several jobs where we can generate the recommendations, generating the recommendations, and an effective search using Hadoop and processing the log files and counting the images, and all the stuff will be dealt while dealing the MapReduce jobs and testing them, debugging them, and performance tuning, MR unit test cases, and advanced concepts of the MapReduce. And then we'll be just discussing with some of the case studies what we usually get incurred with. And then we'll be just going ahead with the Hadoop analyst, where we'll be just discussing on Hive, basic Hive architecture, installing and configuring Hive on your clusters, different sort of tables, library functions of Hive, buckets, partitions, joins, Hive UDFs, and the compressions of Hive, Hive serialization and deserialization, and how to handle JSON data with Hive. And then we'll be just going ahead with Pig, where we'll be just starting with Pig, install and configure, library functions, and Pig versus Hive, Pig basic functionalities, compressions in Pig, running Pig and credentials, and Pig UDFs, Pig macros, Pig parameters, and debugging Pig. And then we'll be just going ahead with Impala, which is almost 20 times faster than your Hive, and which is used for ad hoc querying, and the features of Impala, and the drawbacks of Impala, and the use cases of Impala. And then we'll be just going ahead with NoSQL databases, HBase, a complete description of HBase, and the overview of Cassandra on MongoDB, and the other ecosystem components like Scoop, used to import the data from the RDBMS to HDFS. Practical, we'll just get all the things practically. That's the main reason why we'll consume at least of 60 hours to complete the course. It will consume at least of 60 business hours to complete your course. And we'll be just going ahead with Uzi to design a workflow, and we have something called as Flume, Avro, Thrift, Chukwa, and all the stuff. We'll be going ahead with Hadoop challenges as well, Hadoop disaster recovery, and Hadoop suitable cases, because Hadoop will not suit at all the cases. And every person will be just getting a 100% certification assurance and a certificate from IBM's Big Data University and a technical support, and you can just go ahead with a project, a POC, and we'll be just providing that. And a sample resumes and the interview questions. For sure you'll get all the stuff. So this is these are all the basic highlights of our course. Any technical questions? Or any more? And you'll get this course contents soon. Swati will be updating you the course contents. Sorry. Please go ahead. Please go ahead. You can fire me with your queries. Please go ahead. I think all are unmuted. You can just go ahead with your queries. Please go ahead. Any queries so far?
Vignesh, they're already chatting. They're putting their questions on the chat.
No, here, right? Okay, fine. I couldn't see that. Can you also share how the 60 hours are divided among these topics? Scoop is just a connector. Yeah, Scoop is a tool, utility tool to import the data from your RDBMS to your HDFS. It's an utility tool. It's an utility tool to just go ahead with your to import the data from RDBMS to HDFS, where it will generate a MapReduce job when you import the data. And I did not observe these questions. Will we do Hadoop analytics based projects? Yes. We'll be just providing a project which will be covering MapReduce, Hive, Pig, and the Scoop inputs. So all these ecosystem components. It's a practical project. I'll just share you my source codes and you can just have it. I'll be just sharing you my source codes. Yeah, and what about the software? Is it a free source? I do not much research on this topic. Yes, it's absolutely open source. You can just download it. I'll be just sending you the links to download, and on your PCs or on your laptops on the 4th day of our journey, our administrator will be just Hadoop cluster on your laptops and PCs. Would we have separate project for each participant? Separate project. Because I myself deal with only 6 projects so far. I myself deal with 6 projects so far. I've been with Hadoop from the past 2 years, 4 months. What will be the business domains do we have? Mix of financials, healthcare, marketing. We'll be just dealing majority with the e-commerce, because e-commerce is the place where majority is getting focused on Hadoop, and we'll be just going ahead with healthcare and insurance. Healthcare and insurance. Healthcare, insurance, and e-commerce will be the majority get covered. How much for each part? Well, when I talk about Hadoop basics, it will just consume, I'm talking about the case studies and all, it will just consume at most of 8 hours. And then when we need to install, right, when we need to just go ahead with your cluster building, it will just consume 12 hours because we need to just go ahead with initial single node cluster setup, and then fully distributed mode of cluster, and then Cloudera cluster, and it's a person-to-person approach, and you can just build a production environment cluster. And when I talk about the MapReduce, it will consume at least of 18 hours, where I'll be just talking about several MapReduce jobs and several case studies. And again, when I just go for Hive, it will consume 8 hours on Hive. I'm talking about all features. And for Pig, it will consume again 8 hours. And Impala will be consuming 3 hours. And NoSQL HBase will consume 4 hours again. And Cassandra and MongoDB basics will consume 3 hours. Because I have not configured them according to hours usually. If needed, I'll just make it and I'll send you people so that you can just have a peep through that. I'll be just making according to the hours, and you can just have a peep through that. Any questions regarding the technical perspective?
Vignesh, I'll ask a question on behalf of them. Everybody have a question, like, they wanted to find out after the Hive topic is done, can they have one project, Hive itself? You said you'll be having a project on the MapReduce Hive, but is there any way we can do it? projects for Hive, Big, so that they'll understand that Hive itself a bit.
Right, okay. That doesn't mean, okay, no problem. You can just cover that.
So we can do that.
Yeah, yeah.
Along with major projects, with small projects as soon as each topic is done.
Yeah, yeah, no problem with that.
Okay, thank you. Anybody have any more questions?
What about the IBM certification? Yeah, IBM's Big Data University is an open source university where I'm one of the chamber member of that IBM Big Data University. And you can just get a free certification. It's an open source certification from the IBM. If you will be having 3 attempts and you need to just achieve 60% in any one of the attempt. You'll be having only 20 questions. If you could crack that, you will be getting the certificate that you are suitable for Hadoop fundamentals. Yes, you need to just go ahead on online. I'll be just sharing you how to just approach that. It's an open source certification. No need to have any pay for that. No, question bank is not needed. They'll be just covering the very basics, no problem. I don't have the question bank, but I have the collection of questions for the Cloudera certifications and Hortonworks certifications. Where Cloudera is of $350, the $295, and Hortonworks is of $150. Need to know from business analytics perspective, don't we need to focus more on Hive, Pig, analytics and knowledge? Yeah. So if you just want to have on analytics, the most focused areas are like Hive, Pig and Impala. These 3 are most important for analytics. And R Hadoop, R language, integrating R with Hadoop and R Hive are the most sounding one for analytics. So will you be integrated with, no, sorry, I can't cover R with Hadoop. I'll be just covering all the basics, that's it. I can't cover the entire R with Hadoop. We'll be having a video. Yeah, each and every day you can just record the sessions. You can record the sessions. I'll be just making you as organizers. So each and every day you can record the sessions. Any more? Can you share more on the market trend and skill set and demand as per your experience? Yeah. So the most, if you just want to develop your career on Hadoop as a developer, the most crazy combination you'll see is MapReduce, Hive, Pig, Scoop, Oozy, and a basic knowledge of Flume on any of the NoSQL database. This is the most crazy combination for a developer. And if you want to build your career as an architect, you need to have overall view of all the ecosystem components. If you want to start your career as an analyst, you need to have most focus on Hive, Pig, Impala, and better to have the knowledge of R Hadoop. If you want to have yourself as a data scientist, you need to have the knowledge of Mahout as well. Any more?
Vignesh, are we covering Java sessions also, right?
Yeah, no problem. We'll be just covering the Java as well. Yes, all softwares. I'll just share you the VM workstation, which is a licensed one. I have the cracked version. I'll just share you that VM workstation, and rest of the things, everything is open source. A project will never get completed if you just go for any of the practical project. A project will never ever get completed only with Hive or only with Pig. A project will comprise of all the modules. It will just start with MapReduce, writing a MapReduce job, and then we'll be just joining the data using Hive or Pig. We'll be just extracting the fields, required fields out of your dump from Pig, and then we'll be just generating the reports using Hive. That's an entire project. So a project will never get completed exclusively on Hive or Pig. Of course, we should just see a practical examples like that on the separate each and every ecosystem component. Exclusive project a project will never ever get completed only with these ecosystem components. It's a combination. Any prerequisites for the course? Yes. A person who need to just seek the Hadoop, he need to just have basic knowledge of Java. Of course, we'll be just providing that. No need to worry regarding that. Apart from that, you need to have a basic knowledge of operating system. Since we will be just working on a Linux environment, we'll be just you need to just know the user management and the file system architecture of Unix or Linux environment. The very basic Linux commands. You need to know that. That's it. No need to know advanced Java or even no need to be a Sun certified programmer. No need to worry regarding that. The Java required is very basic. You need to have the basic OOPS concepts, exception handling, collection framework, and you need to have serialization and generics. You need to have very basic of these concepts. However, considering we all from analytics, please see how more of Hive, Pig can be focused on. I'll be just covering entire of Hive and Pig and Impala. No need to worry regarding that. But providing an exclusive project, because I couldn't see till now a project exclusively being focused on any of these ecosystem components. Because a project is always a combination. It will have all the collective work, but I'll just delve much more deeper on each and every concept. No need to worry regarding the technical perspectives. Any more? Yes, I'll be just sharing you my source codes. And regarding the hours per session and the starting date of it, Swati will be just reverting back to you on this, the timings and all that stuff. There is no such constraint that analytics team should only work on Hive, Pig, and all the stuff. Usually developers also working on Pig currently. But if you want to build your future exclusively on analytics, then we need to just have well-versed knowledge of Hive, Pig, Impala, and better to have the knowledge of R and Mahout. Yeah, Linux and Unix material will be helpful. Yes, Linux and Unix commands, it will be provided, no problem. It will be provided. Any more? So we can reduce time for MapReduce and include Mahout and R a bit more. So Mahout is a very big world where I'll not cover complete of Mahout and I can't cover the complete of R. I'm sorry for that.
Right, but Vignesh, can you able to give them the introduction about both of the things, Mahout and R?
For sure, no problem regarding that. I can just give it the introductions and I can just make better interaction with that. But I can't cover the complete of Mahout and R.
How many hours it takes complete Mahout and R?
It will consume at least of 20 hours more for Mahout and R.
Combined together?
Yeah.
But is there any way if they don't want the administration, can we able to reduce the administration and those and be able to add? Is there any possibility?
No, I need to discuss it.
Okay. Ankit, actually you guys can decide because I got the different opinions from each and everybody. Some people want to learn MapReduce administration and everything. Okay, have a chat with all your friends and let me know what exactly you want. We can able to define the course curriculum according to it. That's not a problem. But I want everybody to be on the same page.
Well, so that I should just pack up today and we shall just revert back. I can.
Okay, thank you, Vignesh.
Thank you.
If anybody has any questions, you can ask me. I'm unmuting all. Hello.
Hi, Swati.
Hi, Pankaj.
Swati, this is Pankaj here.
Hi.
Swati, I think we, even among the discussions that we had among ourselves, I think we all agreed that, as far as coverage is concerned, we do want to cover admin parts, the MapReduce, and the whole, the components which are required in the whole cycle. But it's just that, we wanted that the timings can be adjusted, how much time we are spending on each of those topics, if that can be adjusted to suit what is required for analytics career. That was the request. So just wanted your help on,
Yes, absolutely understand. So what I'll talk to Vignesh is, he will give the introduction to the administration and MapReduce. He doesn't have to show you the case studies and all, so that he can easily save 5, 6, 7 hours there. Okay. Also, by learning all these things, he doesn't have to go and teach you Mahout in deep. Even if he gives 4 or 5 hours of introduction about Mahout, you should be able to pick it up.
Okay, right.
Okay, and plus R language. He was talking about 20 plus hours of the Mahout and R. So we'll ask him to cover 10 hours of Mahout and R, 5 hours, so that he'll give you the documentation. Okay, once you have the and once you learn all these things, pretty much everything will be same.
Okay.
In that case, after that you still have questions, yep, then we'll talk about. That is what my take is. If you want to cover everything, it's going to be a lot.
Oh no, no. The request was not to cover R as such. I mean, it's just that we all know that if you're given enough pointers, we can go ahead and learn on our own. So yeah, within the 60 hours, how to make the best use of it. So we'll just wait for the course contents and how many hours are being spent against each of the topics. And we will also discuss among ourselves on when we want to have the start and how we want to schedule the sessions. And I hope Vignesh is open on that.
Yeah, we will check with his timing and we'll try to match your timings also. Okay.
Right.
And one more thing, just let me make sure that Hive, Pig, Impala, whatever is going to cover HBase, SQL, they're 100%. It's not that even though you're focusing on analytics, it's not focusing. It's the total course content itself will teach 100% on MapReduce, 100% on administration, 100% on Hive, Pig and all. So we will keep those topics as it is, Hive, Pig, and we'll cover 100%. And we will little bit reduce on the case studies part of MapReduce and administration. And I'll ask him to give the introduction about the MapReduce or give you little more pointers where you can able to start by yourself, and he'll teach you where you have to get. And 5 to 6 hours of R and this, and I think you should be able to get on it.
Fine.
Okay, and also he'll be giving you 5 to 6 hours of Java introduction, so that it will be a refreshment people who doesn't have Java experience.
Okay.
Okay. And the number of hours never defines, if you guys keep on asking more questions, if you have questions, it could lead to 70, 75 hours also. Don't worry on the number of hours anytime. We'll make sure that you all get the hang on it.
Okay. Pawan, anybody else? Any other question?
Yeah, I think everything seems good. I think people have asked most of the questions. If anybody has got any other questions regarding the course fee or anything, I think they can discuss it with Swati.
Yeah, please ask me.
If anybody has got any question with course fee and the mode of payment, I think it's best to discuss with Swati.
I think the fees will be the same for everybody, right? We just need to let you know, Swati, how many of us are interested and when we want to start.
Yes. Yeah, fees, because he's covering pretty much all of it. As I already discussed with Pawan, based on number of people, if the 10 students are coming, I can do for 400. If more than 10, 15, 20 are joining, I can do 350.
Okay.
Okay, we'll be covering MapReduce, Java, everything. Any questions? If anybody has any, please tell me now.
Is all the payment upfront? How is it?
All the payments are going to be upfront. Yeah, I'll give you my US account number and I also have an Indian account number. Either case is fine. You can be able to do the Zoom transfer, or you can put the money into my Wachovia account, Wells Fargo now called.
Okay, I think, yeah, probably we'll have a discussion, all of us will discuss together, and probably we can get back to Swati regarding the start date and how many are going to join, whatever it is,
Right.
and probably even the finalizing the course content.
Yes.
Yeah,